Today, we'll be deriving the derivative of sine. My name is Vade Krishnan, and let's get started. Let's first let f of x equal sine of x. And we can say that the derivative is f prime of x. And f prime of x we can set equal to our limit definition of the derivative. Okay, and that is the limit as delta x, the change in x, approaches 0, of f of x plus delta x minus f of x over delta x. If you're confused on how I got this, I made a video called Picturing the Limit Definition of the Derivative. I'll link that down in the description below. I recommend watching it if you do not know how I got the limit definition of the derivative. So now we can just substitute this in for f of x. We know that f of x equals sine of x. We can rewrite it as the limit as delta x approaches 0 of sine of x plus delta x minus sine of x over delta x. So now with this one, this right here, sine of x plus delta x, we can actually use our angle sum formula here for sine. Okay, which is, we can say sine of u plus v equals sine of u cosine of v plus cosine of u sine of v. Okay, so now using that formula, we can say that the limit as delta x approaches 0 of sine of x cosine of delta x plus cosine of x sine of delta x minus sine of x over delta x. Okay, so now what we want to do is, for the numerator, we want to factor out a sine of x here with the numerator. So we can do the limit as delta x approaches 0. We want to factor out a sine of x, so we do sine of x. And then this times cosine of delta x minus 1. And then that plus cosine of x sine of delta x. And then that all over delta x. So then here we can just split this up into two separate fractions. So we can do sine of x times cosine of delta x minus 1 over delta x plus cosine of x sine of delta x all over delta x. So now, using our properties of limits here, I'm going to rewrite it as the limit as delta x approaches 0 of sine of x times cosine of delta x minus 1 over delta x here, plus the limit as delta x approaches 0 of cosine of x sine of delta x over delta x. So now, since we're taking the limit as delta x approaches 0, we can treat the sine of x and the cosine of x as constants, essentially. But what I mean by that is we can take these two outside here. So what I mean by that is we can equate it to sine of x times the limit as delta x approaches 0 of cosine of delta x minus 1 over delta x plus cosine of x times the limit as delta x approaches 0 of sine of delta x over delta x. So now what you'll notice here is that we have two of our special trig limits here. So I'll link the deriving special trig limits part 1 and part 2 in the description as well. So if you don't know how I got this to be 0 and this to be 1, watch those videos in the description below. So these are just our two special trig limits, right? The limit as delta x approaches 0 of cosine of delta x minus 1 over delta x is 0, and the limit as delta x approaches 0 of sine of delta x over delta x is 1. So now we'll just have sine of x times 0 plus cosine of x times 1. So then we can just say, therefore, f prime of x, which is our derivative, is just cosine of x. So hopefully you understand here, we're putting it all together here, limit, definition of the derivative, and our special trig limits. In terms of the sine angle sum formula, I'm going to make a bunch of videos deriving trig identities, and part of the bunch of videos that I'm planning to make will be our sum and difference formulas, so stay tuned for that. Anyway, I'll see you guys on the next one.